You type git push, and a few minutes later, strangers are using the change. Nobody logged into a server. Nobody copied a file anywhere. In between, a machine you have probably never looked at decided what production would run. Here's the shape of the problem. Picture a service that ships twice a week. Staging was built on the Monday. The release job ran again on the Thursday. Same commit, same branch, same pipeline. In between, a dependency published a patch, and the version range accepted it. Every test that gated that release ran against the Monday build. Thursday is the one that took traffic. Nothing failed and nothing was misconfigured. There was simply never a moment where anyone could say the tested thing shipped. That is a boundary problem, and this episode is about where the line goes. I'm Nancy, and this is Trust Boundary. Every episode, we take one piece of your stack apart and find the line where trust changes hands, how it really works, what it looks like on the wire, and the one check almost everybody skips. By the end of this, you will read a deploy spec and know what it actually promises. 1. Every stage between your push and a live instance in order. 2. The single object allowed to cross into production and how it is named. 3. Why a change that passes every test can still take the site down. And what really stops it, which is not the thing most people think. Start where the commit starts, on the exposed side of the line. 5 participants, and the line runs between 2 of them. You on a laptop holding a branch, the forge, which stores that branch and tells other systems when it moves. The runner, a machine that will execute whatever the repository tells it to. The registry, which stores artifacts and addresses them by their contents. And production, which runs one of those artifacts and nothing else. You push. The forge fires a webhook, and the CI/CD pipeline starts with no human in it. First, the runner checks out the exact commit you pushed by its hash. Not the branch. A branch is a pointer, and pointers move. Then it restores dependencies from the lock file, not from the version ranges. The lock file names exact versions, and in most ecosystems, their hashes too. This is the step that would have caught the Thursday build. Then it builds. Then it runs the tests, and the tests are a gate. One failing test and nothing downstream of this point executes at all. Notice what the tests are checking, code in the environment the tests run in. Hold on to that. It is the whole failure section. If the gate passes, the run packages the result into one artifact. Commonly a container image, though a compiled binary or a zip file counts equally. The runner tags it with a commit hash and pushes it across the line. That pushes the moment trust changes hands in this system. On the left, everything was a name that somebody could move. On the right, the artifact is addressed by a hash of its own bytes. The registry stores it, and production will ask for it by that hash. Nothing else crosses. Not your branch, not your tests, not your green check. Now the deploy. Say production is running 6 instances of the old version. The rollout does not replace all 6. It replaces a few at a time. A new instance starts, and it does not get traffic yet. It has to answer a readiness check first. Only when it answers does the load balancer add it to the pool. Then an old instance is drained and removed, and the cycle repeats. 6 replacements later, the old version is gone, and nobody outside saw a gap. So what actually crossed? Look at the artifact itself. In the registry, the image has a name that looks like a version. It also has a digest, the word SHA-256, then 64 hex characters. That digest is computed from the bytes of the image manifest, which means the name is the content. You cannot move it. Change 1 byte of the artifact, and it is a different digest. Now compare the 2 ways a deploy spec can ask for that image. By tag, it asks for whatever that name points at when the node pulls. By digest, it asks for one specific file and will accept nothing else. A tag is a promise, a digest is a fact. Go back to the Thursday build for a moment. With a digest in the deploy spec, those 2 builds are 2 different names. You do not have to notice the drift because you cannot express it. The tested artifact and the shipped artifact are provably the same file, or provably not. One honest limit, because this matters. A digest proves sameness. It does not prove correctness. It says this is the file you tested. It never says the file is good. Which brings us to the deploy that passes everything and still breaks. The change is small. A default value moved out of the code into configuration. The artifact is correct, the digest matches, every test is green. The rollout starts exactly the way you just watched it. 2 new instances come up, both fail their readiness check. The setting they need only exists in production, and nobody set it there. Here is the good part. Neither instance ever receives a request. A failing readiness check keeps an instance out of the pool entirely. And because the new instances never become ready, the rollout stops replacing old ones. 4 old instances are still serving, the site is up, nothing is on fire. Now the part that most explanations get wrong. Kubernetes does not undo this for you. After a deadline, it marks the rollout as failed and stops trying. Reverting is a command that someone runs or a delivery system somebody configured. Automatic rollback is common. It is a thing you add, never a thing you get. Look at where those two checks live. The test ran on the cold side against an artifact in a test environment. The readiness check runs on the warm side against a real process in production. Only one of those can see what production actually is. So the last question is how much of production sees a bad version before you know? That is the only real difference between the three strategies people argue about. A rolling update exposes a slice at a time and costs you no extra capacity. Blue-green runs 2 full environments and cuts over at once, so reversing is instant. You pay for that with roughly double the capacity while both of them exist. A canary sends a small share of real traffic first, watches it, then widens. Different blast radius, different bill, none of them makes a bad artifact good. So here's the line, drawn plainly. On one side of your pipeline, everything is a name that a person can move. A branch, a tag, a version range, a green check on a pull request. On the other side, one artifact is addressed by a hash of its own bytes. The pipeline is the machine that stands on that line and converts one into the other. That is what you are buying when you buy continuous delivery. Not speed. Speed is the side effect. You are buying the ability to say which file is running. Production does not run your code, it runs a file somebody built from it. 3 things to go and check today in your own repository. 1. Open your deploy spec. Does it name a tag or a digest? 2. Does your pipeline build once and promote or build again for each environment? 3. When new instances fail their check, does anything actually revert? If the answer to that last one is a person, then that person is your rollback. That is one more boundary drawn. If this made something in your stack, click subscribe. There's a new one every day, and the next one is already in the queue. I'm Nancy. I will see you at the next boundary.